You know, even the most highly skilled nozzle man in the entire world cannot fix a fundamentally unstable delivery system. Welcome to this explainer covering the ACI Shotcrete Inspector course material, where we're going to focus specifically on equipment, delivery systems, and crew communication. If you want to ensure top-notch quality on a Shotcrete project, or, if you're just prepping for your inspector exam, you absolutely have to understand the mechanics behind how the material gets from the staging area all the way to the wall. Okay, here's our roadmap for this explainer. 1. Foundation, dry versus wet mix. 2. Managing the delivery chain. 3. Crew communication. 4. Field scenarios. And 5. Our inspection framework. All right, let's dive right into section 1, our foundation, dry versus wet mix delivery systems. This is absolutely vital baseline knowledge for your exam. Now, listen up, because here is a major exam alert to lock in. The fundamental difference here is exactly where the water meets the mix. So in a dry mix system, dry or pre-dampened material goes into the machine, and compressed air literally carries that dry material all the way through the hose. The water? It's finally introduced right at the nozzle body. Conversely, in a wet mix system, the fully mixed wet concrete is physically pumped through the delivery hose, and then compressed air is added near the nozzle simply to accelerate that wet material. So why does this distinction actually matter? Well, understanding this tells you exactly what can go wrong out there. Let's say you're inspecting a dry mix operation and the air supply suddenly drops. That material is not going to hit the wall with anywhere near enough velocity. Or if the water pressure drops relative to that air pressure, the water just can't penetrate and mix into that moving material stream. What you end up with is this dry, dusty mixture, massive amounts of rebound, and honestly, terrible reinforcement encapsulation. Structurally speaking, the quality drops right to zero. Moving right along to section 2, managing the delivery chain. Let's see how all of this builds into a fully interconnected operation. I want you to think of the entire shotcrete process as this 6-step chain. You've got your material supply, the machine and air, the hose, the nozzle man, and finally the receiving surface. Now, if any single link in this chain, like say a kinked hose or a sputtering air compressor, fails, the whole system degrades. It really acts as one continuous, almost biological system. So, from an inspector's view, here's a pro tip. Don't just watch the nozzle, watch the hose. Honestly, a lot of people totally ignore the hose, but long runs, really tight bends, or incorrect diameters create huge friction and delivery issues. Plus, think about the physics. A heavy, poorly routed hose that's actively pulling sideways makes it physically impossible for the nozzlemen to maintain safe and accurate control of their angle and distance to the wall. Okay, heads up, here is another major exam alert and, frankly, a literal lifesaver. A plugged delivery line is essentially a loaded cannon. Absolutely never stand in front of a hose that is being cleared, no exceptions. And from a quality assurance perspective, you've also got to verify that the production equipment out on the site actually matches the approved qualification equipment. If they qualified with a specific wet mix pump and then suddenly swap it out for a completely different setup, you, as the inspector, need to flag that immediately and verify if additional review is required. All right, on to section 3, crew communication and coordination. Because look, the best hardware in the world is going to fail if the crew isn't in sync. A highly successful shotcrete crew works as one seamless unit, but here is a super common field problem. Imagine a nozzleman needing an immediate stop, but they literally cannot communicate with a distant pump operator over the deafening roar of a compressor. That breakdown in communication creates sudden interruptions and overdelivery that will completely ruin a freshly shot section of concrete. When they can't talk, both quality and safety just plummet. Let's put all this theory into practice with section 4, real-world field scenarios. I want to test your eye with some classic situations you will absolutely see on site. Scenario 1. Imagine you're on site, watching a wet mix placement. The first few minutes are perfectly smooth, looking great. Then, suddenly, the pump starts pulsing heavily. The stream becomes super heavy for 2 seconds, then really weak, then heavy again, but the nozzle man just keeps shooting material right onto the wall. As the inspector, what should instantly trigger in your mind? Boom! You should identify right away that the delivery is completely unstable. That constantly changing stream directly compromises consolidation and placement control. So what's the required action? You've got to ensure they correct that unstable delivery before bad concrete is permanently placed. But, and this is crucial, remember your lane. You observe, you verify, and you report. You do not step in and start twisting dials on the pump yourself. You report the nonconformance so the contractor can fix it. Okay, let's look at scenario 2. You're watching a dry mix placement. Out of nowhere, a blowpipe operator opens an airline to clean out some nearby rebar, and instantly the active dry mix stream visibly weakens. What exactly is the quality concern here? Let's just say it's a lot more serious than simply another tool is running. Here is exactly why it matters. That shared air demand is literally starving the nozzle. When that blowpipe opened, it stole the air volume needed to carry the shotcrete. This directly strips the necessary impact velocity from the stream, which instantly ruins the encapsulation behind the rebar and dramatically increases your rebound. It's simple physics, but it's a huge problem. Final scenario. Material is blasting out of the nozzle at high velocity, but the nozzle man keeps taking his eyes off the wall, turning around to physically shout at a pump operator who's 50 feet away. They might as well be doing a mime routine over the sound of that equipment because the operator clearly can't hear a word they are saying. This right here is a massive red flag. The required action? Pausing the operation immediately. This is a total crew coordination failure. You absolutely cannot have a nozzle man taking their eyes off the receiving surface while heavy material is flying. Reliable communication, whether that's two-way helmet radios or dedicated, clear hand signals, has to be firmly established before another yard is shot. And finally, Section 5, Inspection Framework and Takeaways. Let's synthesize all of these field observations into your daily professional routine. Think of this framework as your ultimate on-site mental cheat sheet. Just continuously loop these 4 questions in your head. What should I see? What am I actually seeing? Why does the difference matter? And what action is required? If you constantly run that loop, you will never miss a critical defect. To wrap this all up, remember these 3 keys. Quality requires stability. You absolutely must know your dry mix from your wet mix, and communication is literally a quality control tool. But if you take away only one single thing from this entire explainer, make it our field takeaway. Always, always watch the stream. The wall doesn't lie. The wall and the stream will visually show you an equipment failure long before any pressure gauge or batch ticket ever does. Trust your eyes out there. Which leaves us with a pretty provocative thought. Let's say the pump is perfect, the air supply is flawless, and the comms are crystal clear. How much does the nozzle man's actual physical stance and technique dictate success or failure? Well, we are going to answer exactly that in our next explainer, Clip 8, where we tackle nozzle technique, angle, distance, and impact velocity. I'll see you there.